the live dance, doing the live dance.
There's a live
And
dance?
hello.
You didn't tell me there was dancing. No dancing.
All right. I am HP Holo / Edie Skye. I write stuff. I also know a ton of other people who write stuff. And occasionally I like to get them together to talk about that stuff. So today is actually a continuation of a panel I hosted about a month ago, because it turns out that I am really, really curious about all the space sciences and space fields. And when you write in a community of military science fiction authors and the like, you tend to know a lot of people who work in space. So welcome to Authors Just Talk About Space Science 2. We are getting a little bit of a late start because of some technical difficulties, but we are still going to have a whole ton of fun. So before we get started talking about space, though, I want to have everybody go down the line. Tell me your name, short author bio, and what you write. So we'll start with Stephanie.
Hi, I'm Stephanie Osborn. I worked in the civilian and military space programs for a couple decades, sat console for numerous shuttle missions, trained astronauts, all that kind of stuff. These days, I write science fiction, sometimes with a military bent, sometimes with a mystery bent, as well as popular science fiction.
All right, Joelle and Andy.
All right, I'm Joelle Presby. I survived the Naval Academy and then went to Naval Postgraduate School, where I picked up this lovely gentleman right here. I was at the time studying, my degree was math, but
let me interrupt you. I think we might have Les again. Les,
hey, we got Les.
Can you hear us?
I can. Can you hear me?
I was doing anti-submarine
warfare
stuff, and I got attracted to a guy who was a submarine officer, and then went off and did the rest of my service Navy nuclear power things, and eventually got out of the Navy, started writing with this very unknown author named David Weber in the Multiverse series, and I've now released my first novel that's just written by me, The Dabere Snake Launcher, and have another manuscript into Bain Books, and have written a number of short fiction in other people's worlds in my own world, and sometimes I draft my husband here to help me design spaceships for my stuff.
She buys me books. Very helpful. Yeah, I'm Edie Presby. You got most of the story. I still work. I still work for a space agency near you. I did 22 years in the nuclear navy and submarines and various other places. Got a degree in spacecraft engineering while I was on the way, and I wouldn't call myself a writer. I'm more like writer support.
You're a consultant.
Yeah.
And Michael.
Benefits.
All right, so everyone, Michael Morton here, retired Air Force Space Operations, now working for the Space Force as a civilian. And I write military science fiction, military fantasy, and I'm also the fantasy editor for Canon Publishing.
And Les.
Well, first off, we can put a man on the moon, but I can't get my streaming to work on my computer. I apologize for the lateness of coming in here. Yeah, hi, I'm Les Johnson, coming to you from about a mile or less from where Stephanie's probably zooming in from, in Alabama. In my day job, I've been at NASA for about, well, you can tell by this, 34 years. I've been there 34 years. I'm currently the chief technologist at the NASA Marshall Space Flight Center in Huntsville. But I write books on the side. Everything I say tonight is my own opinion, not mine and Andy's employer. If this is the time we're supposed to plug our upcoming books, I have a hardcover release next week from Bain Books of Crisis at Proxima, co-written with Travis Taylor. It's in hardcover. It's available just about everywhere, and got a book signing in Huntsville on November 16th. And I'm excited. I'm thrilled.
Nice. All right. So some of you have already answered some of my questions, because Michael and Les, you had so much fun last time you asked to come back for the second version of this. But I am going to posit my first silly question. So for those who did not see Space Science 1, the entire reason why I wanted to run this panel actually happened way back in 2020. Coca-Cola released a special limited edition flavor called Starlight Coke, which was reputed to be space flavored. And I was like, you know what? I have a ton of friends who work in various space things who could probably answer the question of how accurate this tastes. And so my first question to you guys is, one, did you try Starlight Coke? And two, what does space taste like? Stephanie, any idea?
I didn't know it came out. Somehow I managed to miss that entirely because I would have found a way to try it. I don't think space tastes like much of anything. Vacuum is just, it's not a perfect vacuum, but it's just kind of like that. It just doesn't have a flavor. So I think it probably just tasted like Coke, or it should have.
Uh-huh. Anyone in the comments, if you tried Starlight Coke, you got to tell us what it tasted like.
What did it taste
like? Joelle and Andy, did you try?
Forget about space. Was it different than regular Coke? I mean,
I assume so. I didn't actually try it myself, and it's one of my great regrets in life that I didn't try Starlight Coke, because that question is just going to bother me for the rest of my life now.
Oh, you're doing better than me. If that's your great regret, you're doing better than me.
All right.
Oh, yeah, most of my
I didn't
life.
try it either. But I think space tastes like cinnamon with a hint of lime. But then there's ozone scrubbers, so you can't actually taste anything.
Why? Okay, why cinnamon with a hint of lime?
Because whoever is making the bid has to have something that they can talk about. And they're really going to be selling it at all the little kiosks where people are trying space ice cream or whatever it is.
Yes, that actually makes a lot of sense. We have in the comments, Julian Thompson says space tastes like Darth Vader farts. I will accept that as an accurate description. And Michael and Liz, you answered this before, but do you want to answer again?
No, I think Andy would agree with me. Any sort of, obviously, yeah, you can't taste in space, but any sort of space vehicle, if it's been up there more than a month, is just going to taste.
You don't want to know.
Yeah, you don't want to know.
But space is big, and it depends on where you're talking about in space. Because I recently read an article about some of the experiences that Neil Armstrong and Buzz Aldrin had on the moon. And they said that after they got back in the lunar module, after they'd been on the surface and had all the lunar regolith dust all over their suits, they said that all they could do was smell and taste gunpowder.
Yeah.
And that whatever the lunar dust is, it smells and tastes like gunpowder. So depending on where you are in space, there might very well be a taste. And I doubt very seriously that Coca-Cola released a gunpowder flavored soft drink. So.
Your Second Amendment right to Coca-Cola.
Yeah, Second Amendment right.
You got me curious as to what gunpowder tastes like now.
I just know what they said. Go look it up. Yep.
Sometime
You're gonna get some sulfur in there.
Based on tastes from other planets. We're gonna have like Jupiter flavored Coke and something one day, I bet you. All right. So next question. What led you to enter your respective fields to begin with? And we're all science fiction writers here, or you guys are. I'm not. But did science fiction play a role in you deciding to go into some space related field? Let's start with Joelle.
Yes. I'd always liked telling stories, and by the time I was in high school, I was sure that I wanted to write as an adult. And I had researched into what it took to be a professional novelist. And I had decided that the chances of being sure that you could make a living off of it, because I also wanted to eat, were not high, and that it wouldn't necessarily be related to the amount of effort. And so I had a plan to become independently wealthy and write anyway. And I guess my idea of wealth wasn't also that high, because my plan was to go into the military, do 20 years, get the retirement, and then live somewhere inexpensive, not near a coast, and do it that way. And so then I found out that there existed these things called service academies where you didn't have to pay for college. And West Point sent me the first mailing because I had taken the SAT and done very well, and gotten to that magic number where they start inviting you to go instead of asking you to apply, and offering you scholarships and stuff. And West Point sent me their package, and my parents were not pleased with the idea of me going to the Army and absolutely forbid it. So I had a week of arguing before I got the paperwork from the Naval Academy. And I had my grand plan that, all right, the Naval Academy had produced Robert A. Heinlein. So there was an example of you could go there and make it work. And also, I had not really given up on the Army. I decided the Marines were like the Army, but just as good. And I could go to the Naval Academy and be commissioned as a Marine.
Nice.
Thankfully, when I was at the Naval Academy, I learned a little bit more about the Marines and realized that I was not actually the kind of person who would do well in the Marine Corps. And I kind of chose the exact opposite and was in the Navy surface nuclear power track instead, which
very different from the Marines.
A lot of Marines do max out the physical fitness part of the officer qualifications, and a lot of Navy nuclear power officers and enlisted are on waivers for not really being able to pass that part.
How about you, Andy?
Yeah, I'm going to give you the short version. Here. It was 1979. My daddy took me to see Star Trek: The Motionless Picture. I was 4. I thought this damn thing was real.
Oh.
I've been trying to build it ever since. Everything I've done pretty much past that was because of that.
Oh, I love it.
I went to Carnegie. I went to Carnegie Mellon, got a physics degree, discovered I was too dumb to invent the warp drive. But I learned about these things called fusion rockets, which are basically the impulse drive. And I went, oh, those look interesting, but they're nuclear. Where do I learn about nuclear stuff? Ooh, being a physicist is about writing grant proposals. That doesn't sound like any fun at all. I like submarines. They're like starships. I walked into the ROTC recruiter's office. Can you make me an officer on a Los Angeles class fast attack submarine? He looked at my grades and said, yeah, probably. I guess they were desperate that year. And here we are.
All right,
now I work at NASA on nuclear propulsion systems. So I am slowly trying to build the impulse drive.
Yes. All right, Stephanie.
I feel really old about now.
I'm sorry. Wait.
He was 4. He was 4 when he saw Star Trek: The Motion Picture for the first time. Oh dear Lord God.
The original series.
Okay. All right. So my tale of how I got into all of this involves Star Trek as well, but not that one.
Yeah, no, of course.
Because see, I was watching Star Trek when the Apollo 1 fire occurred. The original Star Trek, the series.
Mm-hmm.
And I was very, very excited over the TV show and very overwhelmed by what happened in the fire. And I remember that it was kind of like, wow, these guys thought it was important enough that they were willing to die for it, and they did. It was an accident, but still.
Mm-hmm.
And so they were trying to do this. But this over here is where we might wind up if we do this.
Amen.
I want to help get from here to there.
Mm-hmm. Amen.
And I was probably not much older than you were when you saw Star Trek: The Motion Picture. And from then on, the majority of my education was with an eye towards working in the space program. And I did. And then we lost Columbia. And Columbia was not only the bird I worked with the most, it also had a friend of mine on board.
Oh, no.
That I had helped train for her first mission.
Mm-hmm.
Kalpana Chawla, yeah. KC, we called her. And by that time, I actually was working on my first novel. And Travis Taylor, who Les mentioned, is coming out with a book soon. My husband introduced him to me, and Travis became my writing mentor. And so he actually had my first novel, reviewing it, reading through it, and he was going to help me polish it and find a publisher for it. Well, my first novel came so close to predicting what happened to Columbia, with the sole difference being the fictional scenario was sabotage. That Travis had to talk me out of trashing the manuscript. And so it took me a long time to finish it because I was still working in the program, and it hit a little too close to home. It hit way too close to home.
Oh yeah.
But eventually I did finish it. He did help me get it published. Now I'm 60 some odd titles later. So,
wow. I didn't realize you had written that many. Like, I knew you'd written a lot,
well,
but wow.
I've written novels of my own. I've written several series. I've co-authored novels, and I've submitted to quite a few anthologies. So yeah, I got a bunch of titles under my belt. So
Yeah, that really is.
I stay busy. So yeah.
By the way, if you would like to read the stuff written by anybody on this panel, those in the chat, I have all of their websites and whatnot listed in the show notes, so go buy all their books. But all right, next, Michael. Can you hear us, Michael?
Yeah, I didn't set out to be a writer. Didn't set out to be a space officer or anything like that. In college, I started out electrical engineering, and one day in my freshman year, I was coming to a tutoring session. The school had a thing where the juniors and seniors would tutor the freshmen in various math and other subjects. And I got there a little early and walked into the room. And there in the center of the room, the juniors and seniors were gathered around a table. And they were having this just absolutely passionate argument over materials properties. And I asked myself, is this where I want to be in 3 years? And the answer was no. So I went back that night to my dorm room. I got out the course catalog and just started at A for all the different degrees that school offered. I went to UCLA. And I ultimately selected astrophysics as my degree because I said, hey, look, this looks really cool. This isn't, this didn't just actually, kind of like sound like an interesting thing like electrical engineering did. Because back in that day, everybody wanted to be an electrical engineer in Los Angeles area. So about my junior year, I started, thinking, what am I going to do with an astrophysics degree once I get out in the real world? And come to find out that just about everyone who graduates with that degree ends up at an observatory on a remote mountaintop somewhere, working for a PhD who's writing a paper about something. And you're hoping that you do a good enough job that you get mentioned in the paper while you are doing your own graduate studies to become a PhD. And once again, I asked myself, is that where I want to be? And the answer was no. And then I found out that the Air Force could use astrophysics officers, or physics officers, really. So I applied, got accepted, and in their infinite wisdom, the Air Force sent me to be a missile operations officer. Had absolutely nothing to do with physics. As a matter of fact, my 20 years in the Air Force, I've used my astrophysics degree about that much. But I found a job that I liked, obviously, since I stuck with it for 20 years and continued with it afterwards. Along the way, I learned systems engineering, learned about communication systems, learned about a whole bunch of things. And I became a writer because J.F. Holmes, who runs Canon Publishing, one day on Facebook, when I posted just a little something, a little dialogue piece I've been working with, just, for fun, he asked me if I was published yet. I said, wait, you want to publish me? He says, of course. I said, no, this is a joke, right? But so it's one of those things. I haven't accomplished anything I've set out to do because I've always found more interesting things along the way. So I've just stopped trying to make plans, and I just enjoy what comes along.
Cool. All right, Les.
Well, I'm really blessed. I'm doing what I've wanted to do since I was about 7 years old. That was how old I was when my parents woke me up to watch this little grainy image on a black and white TV, those of you who might remember black and white televisions, and that was of Neil Armstrong walking on the moon. And shortly after that, I watched, I think it was probably the Disney TV show on Sunday nights, where they were talking about man in space, and everybody they interviewed had a German accent. So it was,
Yeah.
Wernher von Braun and Willy Ley and all the big experts at that time. So I was about 8 or 9, and I decided that I wanted to work for NASA. And I knew that you had to be a scientist. I didn't know the difference between a scientist and an engineer. So I picked, physics because it sounds cool. I had no idea what a physicist did. And I thought I'd have to go study math, physics, and learn German in order to work on the space program. But I quickly figured out the German part wasn't required. The physics and math part certainly was, and that's what I studied in college and then in graduate school. And of course, I read science fiction all along the way. I did watch Star Trek. My older sister, I vaguely remember staying up late on Friday nights to watch the reruns of Star Trek. I don't remember the original run, but it was on late at night, and I would get to stay up late on Friday to watch with my sister, and love
Now I
it.
really feel old.
Well, no, we're not that much different in age, Steph. It's just you remember stuff from a younger age than I do, because I don't remember much before I was about 8 or 9.
Les and I go back to graduate school together,
Yep,
guys.
that's where we
okay.
met. Yep, we met at Vanderbilt back in 1985. And so, but I always read science fiction. I started reading a science fiction novel a week, basically.
Wow.
Hard science fiction. It kept me inspired. And then in the mid-2000s, I had the opportunity to co-write a nonfiction popular science book, not a textbook. I'd written a lot of technical papers. And it sold. And I got to write a few more popular science nonfiction books, and they sold with my friend and colleague, Greg Matloff. And then my fiction writing kind of began in a barbecue joint here in Huntsville. And Stephanie
Which
mentioned
one?
Crab. Well, I don't remember. It's the one on University Drive across from where the Holiday Inn used to be, down near the Fog Cutter, where the Fog Cutter used to be. Anyway,
Yeah.
I don't remember, but it was during Constellation, the science fiction convention, probably in 2011 or 2010. And Travis Taylor am I frozen again? Yep. Anyway,
No.
Travis Taylor just published his first novel, and we were sitting in a booth talking about how boring NASA makes space exploration sound. You get all this, you're about to go into the most deadly environment the universe can throw at humanity to survive in. The vacuum, the radiation, nature's out to kill you at every turn. It is the ultimate man versus nature theme. It makes the call of the wild look like a picnic, in your neighborhood, right? And we were talking about that, and it turns out Travis's publisher, Tony Weiskopf at Bain Books, was basically in the barbecue place and walked up and said, "Send me a novel proposal. It sounds like you all have some ideas about how you could make an interesting novel out of this." So we did, and that became my first science fiction novel, co-authored with Travis, called Back to the Moon.
That's
And then
awesome.
I've written some of my own novels since then, but Travis and I still collaborate quite a bit.
All right. My next question, and I actually think I asked this one last time too, but it's exciting space stuff has happened even since our last podcast. So we live in a really, really exciting period for space technology. And so my question is, what do you think has been the most exciting advancement of, say, the past 5 to 10 years that has emerged? And let's see. Les, do you want to take that one first?
Well, I can take two different things. From the technology point of view, there hasn't been a whole lot. But from the business side, it's been huge. And that's what SpaceX has done with the reusability of rockets and lowering the cost structure for launch. I'd love to say that that's all the result of technology, and they've done some great stuff with their flyback boosters and figuring out how to reuse these systems. But I think the real innovation was the business model. And what that's done is that's dropped the cost of launch dramatically, which is allowing a lot more people to go to space and might actually enable the space diaspora we all envisioned and thought would happen after Apollo, but didn't, right?
Mhm.
And I think it's in large part to the business acumen of Elon Musk and SpaceX. From the science point of view, I think it's all we're learning about exoplanets and the fact that there are other planets out there, what they're like, and actually starting to learn a little bit about their atmospheres and what these other planets are like. So kind of a business, technical, and a scientific.
How about you, Michael?
So I would say in the last 5 to 10 years, the explosive growth of commercial imaging services. The number of companies out there that are offering what previously used to be only government capability is amazing, and the resolution that they're getting, is in optical alone is something that was a dream 20 years ago, or locked away in the NRO's vaults. So the number of things that we can do today, and we are still learning how to use all of the metadata that comes with commercial imaging. It's just incredible, and it will only continue to grow from there.
Someone's dog is excited.
They agree with you.
If your pets show up, by the way, please feel free to show them to the camera. We love pet photo bombs here. All right, Stephanie.
Oh, you know what? I'd have to say that Les already answered for me in every point. I got to agree with everything he said. I will also say that watching that booster land and be caught the other day was absolutely just so cool. So, but again, it's not that we haven't had the technology to do it. It's just that Elon figured out how to make it practical to do from an economic standpoint.
Yeah, I have to say, one of the things that's been most fascinating for me is that there are so many launches and experiments happening in that respect now that I can just look on Facebook and be like, oh, there's another rocket launch happening today. Okay, scroll on. And it's just a thing that's happening commonly. And it's like, intellectually, I know it's crazy exciting that it is happening on that scale. But it's so cool that it's so comparatively common now. Joelle,
I think that's what.
Yes,
I was just going to throw in a factoid there. This is one of those neat little facts. Over half of all the satellites that have been launched since Sputnik at the dawn of the space age in the 1950s, over half of them have been launched by SpaceX.
Really? I didn't realize it was that big a number.
Starlink. The Starlink constellation is huge.
It's huge. So anyway, that was the factoid of the day.
Oh, there'll be more.
All right. Joelle and or Andy or both, whoever wants to go.
You want it?
I don't have anything new to say, just more geeking out.
Yeah, I certainly agree with Les. I think the biggest thing is definitely the dawn of the reusable rocket. I got to say, though, that as a guy who wants to build the Enterprise, I wish Elon and SpaceX all the joy in the world of getting to Mars. But if all they give me is LEO, if all they do is give me cheap ground to low Earth orbit transport, I got you covered for the rest of the solar system. Right? Because that's the second thing that I see happening. It hasn't happened yet, but there's a lot of work. We kind of walked away from nuclear power in space. Honestly, the last time we did anything and built hardware was the 60s. And it looks like because of, I don't care if you're red or you're blue. I don't care if you want to save the planet from climate change or if you just want cheap electricity to drive industry. People are taking another look at nuclear all over the world: China, Russia, Europe, Japan, us. And that private capital flowing into solving that terrestrial problem, I think, is going to give us some really amazing propulsion systems.
Are you looking at the NERVA type propulsion system?
Both.
Okay.
People ask me, is it nuclear thermal propulsion or nuclear electric propulsion? What is it? And I say, that's like asking Orville and Wilbur Wright their opinions on ducted turbofan jet engines. They had a lawnmower engine. Like, I think once we get these things off the ground, the next generation of space engineers is going to be like, oh, I know how to build a reactor. Like, they will build the impulse drive. They'll build a reactor that will do way more than we can imagine now, because nuclear technology is very early honestly, it's early in its S curve. It's technology development cycle. On the science side, though, I do have to say, just as a guy who supports a science fiction author, basically, I can go on a NASA website and get a map of every rock in the solar system, of like almost every rock in the solar system, above 1,000 kilometers in diameter. I can get a map of the moon. I can get a map of Mars. I can get a map of Ceres. I can get a map of Vesta. I can get a map of every single moon of Saturn, and there are 63 of them, right? And it's like, whoa, that's amazing.
That is super cool.
Like people don't understand the solar system bodies, like mountains, everything has place names.
Mm-hmm. I feel like I need to write more science fiction now just so I can make use of this, because I'm primarily fantasy. I'm missing an opportunity here.
The Dragons of Europa. There you go.
Yes, there we go.
With the covers you have, they'll definitely make people interested.
That's very true. Oh my gosh, yes. I want to write a space book under this pen name now. So
Yeah, some might say that your characters are already experiencing zero G.
yeah. For those who are not familiar with my Edie Skye pen name, you may want to be careful about where you look at the book covers, shall we say. All right. Next question. Now, when most people think of space exploration research, they think in terms of the really dramatic technologies that are going to take us off planet, like space shuttles and the like. But space research often results in subtler benefits that have the potential to affect people in their daily lives. So, in your opinion, what are the most profound improvements that space research has made to civilian life? Kind of a complicated question. Stephanie, yes.
This right here. This packs way more computational ability in it than the entire Apollo spacecraft had. Miniaturization of electronics is one of the hugest things to come out of it.
Mm-hmm.
There were lots of other things to come out of it. How many of you know that Velcro is a space program product?
Oh, I didn't know that.
Yeah.
There are so many things I use for stupid stuff that came out of space. It's like...
I've got a smartwatch, and I'm handicapped for those that have never met me in person. And my husband died a few years back, and I have a 2-story house. This is my help I've fallen and I can't get up device.
Mm-hmm.
And I have actually used it for that. Have fallen in my house. Once I'm down, because I have bad knees, I have a hard time getting back up. I actually called a friend to come over and come in and help me get back on my feet. I also nearly knocked myself cold on that one. So a lot of the stuff that we take for granted is actually part and parcel of space program side effects.
Mm-hmm. How about you, Michael?
So I'll take Stephanie's example and dive into that. The imaging, we'll go back to that. How many people use their map application, Google Maps, Apple Maps, what have you?
Yes.
None of that would be possible without continuous and continual remapping of the Earth's surface to include geodetic measuring of the various gravitational ups and downs of the planet. To go along with that, the space weather, right? You've got the satellites that are showing us the picture, so you can get an idea of whether or not you need to bring your umbrella or a coat that morning when you go to work. It's so, I think, becomes so inimical to what we do that if we were ever to lose it, a lot of the younger generation, they don't have the skill set to operate without it.
That's very true. Joelle and Andy.
Solar panels.
Yes.
Right? If you like green energy, or if you just like being off the grid, I think the technology curve for solar panels looks a lot harder if space doesn't need them.
Mm-hmm.
And space definitely does need them, because as soon as you start going in the outer parts of the solar system, there are things that you've got to have. You've got to have power. The further out you go, the less effective those are. But in the middle range and the inner solar system, yeah, it's great.
Which is, by the way, why I have a job, right? I mean, the only reason you want nuclear power in space is either because it's too dim for solar panels because you're too far out, or you need so much power in such a tiny package that that solar just won't cut it in whatever environment you're in.
And for anybody that thinks that, oh my gosh, they're sending up, this nuclear thing on a rocket, it could explode, blah, blah, the whole eastern coast could be contaminated. No, it's about the size of a marshmallow on general rules. So yeah, no, the whole package.
Yeah.
Oh wow, that's itty bitty. Joelle, did you have any you wanted to add?
I'm a little hesitant because I'm not as knowledgeable at this area as I'd like to be before talking about it, but I'm just going to go out there. It's possible that the civilians in Ukraine would be speaking Russian right now if there weren't Starlink around.
That's true.
I'm just going to toss that out there as a possibility.
Yeah. Les?
Well, I'm going to be the one who just really is the bull in the china shop here. I wrote a book a few years ago called Sky Alert When Satellites Fail. And I would say that if we suddenly lost all our satellites, the economy would collapse and millions would stop. And the reason I can be so bold as to say that is the GPS constellation is what allows us to have just-in-time inventory and shipping. Aircraft fly using GPS. Trains went to something called positive train control a few years ago. So all of our train tracks and all of the cargo that's on trains and ships all navigate by GPS. The weather systems that we talked about, the mapping, there's a system that I learned about because I was at Dollar General doing a honeydew stop on the way home from work, and the cash only lane was the only lane working. So I got in the cash only lane and I said, what's going on? And the manager said, well, our satellite link went down and we can't process telecheck or credit cards because the internet's not secure anymore. We use encrypted satellite links. And so he said, if you go out and you look at the top of Walmart, any major chain, and you see a satellite dish on the roof, it's not for the break room so they can watch video games and movies during lunch. It's to do transactions. The big banks send overnight hundreds of billions of dollars around the world via encrypted satellite links. So, not only Joelle with the military applications, helping us know that the Russians and the Chinese haven't launched missiles at us and we don't accidentally start World War III, I think the whole economy would seize up without space. It's about a $500 billion revenue industry right now. It's projected to be over $1 trillion by the end of this decade. And I think we can't survive without our space assets as a technological civilization. So
yeah, even
try
even
to sleep tonight thinking about that.
Yeah, even without the satellite links, if you still use landlines, you still need your GPS for the timing to make sure that those transactions are actually posted. Wall Street would collapse in an instant.
Yeah.
Every cell phone tower has a GPS receiver to sync the time, so all these data packets can be routed correctly. GPS goes down, Steph, your phone's a paperweight.
Yep, you're right.
I actually had my own solid reminder of how all these space-related technologies affect me because, I was in the area that was hit by Hurricane Helene a while back, and luckily my immediate area generally came out okay, but there was a solid period where phones were basically bricks, and all of satellite-related things, power-related things, but I actually remained pretty comfortable through the whole thing because I had solar panels and a solar battery, and that made a huge difference in terms of general comfort. And so I have a whole new appreciation for these technologies that came out of space research now.
Now there is a new capability that Apple has added and some of the Android phones have, and that is messaging via satellite. If you get the SOS with the little satellite dish at the top, that means that you've lost your regular cell phone network connection, but you can still send a very limited text message via satellite, usually used for 911.
Useful in those kinds of situations. Yeah, I didn't know that.
And the federal government, it's not like people aren't aware of the vulnerabilities Les and Michael are talking about. The federal government does have infrastructure projects in place to look at alternatives to GPS timing and things like that. There's nothing innately GPS timing works because there's atomic clocks on the spacecraft. Every Navy ship carries an atomic clock. They're not something that are innately space related. It's just the place where GPS is. It's really, really easy for everybody to go read that clock because it flies overhead.
Yeah. Yeah.
All right. Next question. Did everyone answer that one? I forget. Okay. What is your favorite space-related mystery, and would you like to see it solved in your lifetime, or would you like it to remain a mystery? This is a fun one. Joelle, you look like you have an answer.
I want to know. I'm going to call it Planet 10 because Pluto remains in my heart. But that mystery other planet out there, it's my favorite mystery, and I'd like to know.
Mm-hmm. Is that the one that could possibly be a black hole? Is that, or am I thinking about something different?
I don't think so.
Probably not a black hole, unless black holes work differently than we thought they did.
Oh, okay, yeah.
No. Just a big Oort cloud object.
How about you, Andy?
There is, I think it's the Perseus cluster, keeps emitting a weird X-ray band emission that I really, really want to be an alien fusion torch, but probably isn't. That's one of them.
Something that we can backwards.
Something that I can reverse engineer.
Yeah. How about you, Michael?
I'd like to know what's in the oceans on Europa.
Working on that.
Mm-hmm.
And hopefully within, 2028 is the juice flyby? I don't remember off the top of my head.
I don't know.
No, that doesn't sound right.
There's juice from the ESA launched, and then we just launched
Europa
one, right,
Clipper.
Les?
Why the oceans
Europa
of
Clipper
Europa
that was
in
launched?
particular?
What's that?
Why the oceans of Europa in particular?
Because he read Arthur C. Clarke.
Because Clark told him not to land there. And he works for the Air Force.
No, I mean it's posited that the oceans on Europa, underneath that layer of ice that's at the top, there could be geothermal vents that are actually warming the bottoms, and life could be growing there. So who knows what could be happening there? There was actually a really good series. The name of the author escapes me, but it was basically Space Marines carrying the USMC tradition into space. And the third book, I think, was U.S. versus China on Europa.
On Europa.
There was something underneath the ice, of
I
course,
remember.
which made it all very interesting, and not just a military flick. But from a science perspective, it would probably be the environment that we would be most familiar exploring, considering everything that we've done to explore the oceans here on Earth.
Mm-hmm.
So to be able to explore the oceans of Europa in the same way, and see, if the same processes that are taking place on Earth are taking place down there, that's a huge mystery that needs to be addressed.
Oh yeah.
But you've got to do it in a way that doesn't contaminate it. So
Which is a huge
Yeah.
you don't want to bring something from here and deposit it there and have it grow. That's like bringing kudzu in,
Yeah, you're not trying to colonize Europa.
Yeah.
Someone needs to write this book though, because I'm curious now.
People have.
It's going to make great sci-fi. Stephanie,
People
how about you? What's your favorite space mystery?
Oh, geez. Actually, going back to my background in astronomy and astrophysics, is the universe open or closed? What's the geometry? What's the, so that's, will we ever know? Probably not.
Uh-huh.
And it's amazing
But
how
I'd
many
like-
times in the past, 20, 30 years that they've gone back and forth on,
Oh,
we've
yeah.
discovered something that says it's closed. Oh, now it's open. Now it's closed. Now it's open. It's the proverbial cat at the universe's door. It's always wants to be on the other side.
Yes.
How about you, Les?
Well, this is the physics nerd in me coming out. I think it's the dark matter, dark energy problem.
Yeah, that's
Because it's going to require a whole new physics, and my hope is that new physics gives us a loophole so we can get the warp drive and we don't have to putz around on it.
It also will help determine the answer to my question, to my mystery.
Yes.
I'll get the warp reactor ready. I'll get the warp core ready. I'm building the power system so that we can power the warp drive whenever you guys invent.
All right.
Make
as
it
soon
so,
as we have the
number
new
one.
physics, we're going to be on our way.
All right. Next question. What are the current greatest challenges involved in moving humanity off planet?
Energy.
Basically.
People's will.
Mm-hmm.
I think that's the biggest problem. Is that people lost interest.
Mm-hmm. That actually leads me to another good question after this. Let's see. Michael, how about you?
I'm going to have to go with a big one, bioenvironmental, to include closed loop systems, hydroponics, all of the stuff that we're going to need to bootstrap ourselves with on a new planet, whether it's Mars, Europa, or wherever, right? We're going to have to carry everything with us to then start something that can be self-sustaining. And we haven't had to do that. So, or at least not since, the early days of the pioneers, where at least, they had soil that was receptive to what they wanted to plant, but we're not even going to have that. So, we're going to have to take whatever is offered to us and turn it into something that we can use to grow food, to make materials. Basically, you have to do everything ourselves.
Mm-hmm. How about you, Les?
Well, I'm going to agree with Stephanie. I think we could do a lot if we really wanted to right now, and I think it's a matter of priorities, and that boils down to money. So it's all right there.
Joelle and Andy, did you have anything you wanted to add on the energy front?
I think
energy is pretty straightforward.
Energy is pretty straightforward. Energy. The reason that I do what I do is because I can solve a lot of astronautics problems by building a spacecraft that can carry more stuff, basically. And to do that, you need more power. Kirk wasn't wrong. Scotty giving more power. Like he wasn't kidding. And so I can spin the ship and create artificial gravity to solve a lot of your gravity problems. Are there issues with that? Yes, there are. But it looks like a pretty straightforward engineering solution to a biomedical problem. I can carry more food. I can carry more energy to make up losses in my closed loop life support systems. And I can get there faster, and I can carry more radiation shielding so I don't cook the crew. There's lots and lots of reasons why having more power density, more power per pound in your spacecraft is really, really helpful. I mean, there's a reason why when Gene Roddenberry went to JPL to ask what his starship was powered by, they went with the most energy dense substance known to our science at the time, which was matter and antimatter, right? Because they knew it would take a lot of power to do what he was talking about.
Mm-hmm.
The other pieces, and I almost hesitate to bring this up, Stephanie, because you had a personal connection with Dr. Chowa, with Kalpana Chowa, but people don't understand. Yes, it's money. Yes, it's will. But I don't think people, when we talk about mining the moon, and I'm a big believer in space settlement and doing a lot of the things we're talking about, I am all in. But when we talk about that, we got to understand, if I understand the mission record correctly, the day before Columbia, Dr. Chowa made a new discovery about fire.
What?
We've been using fire for 100,000 years minimum. Fire and combustion are absolutely essential to every industrial process basically known to man. Mm-hmm. If you want to build an industrial civilization off Earth, we got a lot of R&D to do. A lot. Big time. And that's what the Artemis program, that's part of what the Artemis program is doing. It's part of what NASA's Moon to Mars initiative is trying to do, is learn how to do all these things. And learn where resources are, learn how processes work on other planets, learn how we get oxygen out of the atmosphere. We just did that on Mars for the first time, I think last year, right, Les?
I believe that's right. Yep.
Yeah. And so I want to do it. I want the money. I want thousands and thousands of people working on it, and I want us to have the will. But I also don't want to lie to you. It ain't going to be press a button and it happens.
Mm-hmm.
No, not at all.
We're going to have to work at it.
And as was mentioned earlier, space is inherently inimical. People will die during the effort. There's no way to prevent that. I know that. That one just hit a little closer to home than I expected it to.
Yeah.
But yeah, and I think everybody's like, oh, we should just go straight to Mars. Forget this going back to the moon. No, that's where you learn.
Mm-hmm.
That's where you learn. in a location that is close enough that if something does go wrong, you can get there with a rescue mission, hopefully in time.
Mm-hmm.
When we built the USS Nautilus and sent it out to sea for the first time, we didn't send it under the Arctic ice pack the first day out.
Yeah. All right. This actually
Just because there was a Roanoke colony doesn't mean we should do that again.
Yes.
That should be the plan.
The mention of willpower being significant actually leads me into my next question. Now, space exploration, as we've seen, is very much a really expensive, really long game endeavor, and most of us are probably never going to see the greatest benefits of it in our lifetime, which is why I think where some of the lack of will comes from on a larger scale. So what then is the overarching benefit of space exploration research? Or put another way, how do you convince someone who's skeptical of space programs that it is in fact worth the effort?
I've got to
because we all know it's cool.
Here, though, to our host, and this is strictly Les's opinion, not that of my employer. So I'm just going to give an analogy here. Yes, people have this impression that space is more expensive than other things we do. If you look at the amount of money spent on NASA, it's roughly $24 billion. That's a lot of money. Our government annually spends over $5 trillion. That's 5,000 billion dollars. So if you were to take
exploration program is a steal by comparison.
Take a penny, and you say that represents $1 billion, and you stack up NASA's budget, it's about this tall. Okay, that's 24 pennies. Now throw out 5,000 pennies and tell me that it's a big part of the budget. It's not. Okay,
and realize that budget has not really changed since its inception in the early 1960s.
In real dollars,
it varies by a few billion, but on average, and it has not even been adjusted for inflation.
What?
And the other thing is, I challenge all your listeners, is when you're listening to news reports about what things the government does, every time something is talked about with space, they always describe the cost of the thing. How often when there's a wreck on the interstate do they say, this car went off the road on the $14 million bridge? Or do they say, that the ship at sea sailed underneath the Brooklyn Bridge, which in today's dollars cost X billion dollars to build? They don't do that.
That's a very good point. Yeah.
But whenever you're talking about a space mission, some reason the media always puts in the cost. But they don't do that about all the other federal programs and the things that you see in your life that involve federal spending. And therefore, people have this notion that it's expensive. But when you put it in the context of the cost to build an interstate, it really isn't.
Michael, back me up on this. They do that to defense too.
Yeah.
They do that with defense too. Today, USS San Francisco left port, San Diego, California, headed out on a 6-month Pacific deployment. The 150-person crew of the $2.2 billion submarine. ...
Yeah.
They do.
Well, that defense might be the only other thing, because you just don't hear it about everything else.
Yeah.
I'm trying to think of other subjects that I hear it about. Now that you mentioned it, I really, really don't.
Yeah.
No.
Sierra something says they think the money goes to a bank in space and is no longer available on Earth. Yeah, yeah. So when my family tells me that we spend all this money in space, I'm like, yes, that's what we do. We pour it into the rocket and light it on fire. That's how we get to space.
Some people seem to think that.
Oh yeah, and we've already talked about some of the
walked
smaller
all over
benefits.
your question, but I just had to get that out. So
Well, I'm glad for the clarification, because it was something that I didn't even think about in terms of comparison. But I had my brain just turned off. I had a comment and I completely forgot it. I was saying that we've already discussed some of the immediate civilian affecting results of space research. But how do you convince the skeptics? What's your argument for why we should be going to other planets, why we should be going to the moon, why we should be building a Mars base?
So there's 3 basic reasons why somebody expends a lot of money and or effort on something: fame, fortune, and legacy. And that's where you have to convince somebody. Either you're going to be famous now for what you spent on something, or your legacy is going to be, a moon base named after you, a Mars base named after you, whatever, or you're going to make a lot of money by doing this. And I think Elon Musk is probably motivated by all three. But
Fortune and glory, kid.
Fortune and
Yeah.
glory, yeah.
yeah. So, but those are the three major reasons why you would want to convince somebody with a lot of money to fund space, if they haven't already convinced themselves. I mean, the space industry, all aspects, is, a multi-trillion-dollar industry around the world. You can't avoid it. China, back in 2007, when they tested their very first ASAT that created a cloud of debris, they had 3 government satellites on orbit. Nowadays, they have almost as many as we do. That is the amount of money and effort that they have put in to their military and commercial space programs in order to catch up to us. So the space race is on, and it's real. It's just a corporate space race, not a government space race.
It's a little of both, because let's face it, I'm sorry, China is all about the government.
Well, yeah, for them, it's indistinguishable, right?
Yeah.
For us, it's a little less, and we're trying to convince people. Elon Musk is certainly doing a great job of that. But as you pointed out, NASA's budget hasn't changed, and so the government really, they're not in it to win it like they were back in the 60s.
All right, Stephanie?
What was the question?
Oh, it was, how do you convince someone who's skeptical of the space program's worth that it is, in fact, worth the effort?
I remind them about the dinosaurs. There's pretty much little doubt anymore that the Cretaceous Tertiary extinction event took place as a result of an asteroid impact. A fairly good-sized asteroid impact. There are more out there.
Oh, yeah.
It is not a question of if. It is a question of when. If you stick enough time in there, the probability becomes 1 that there is going to be another major impact. And it would be really, really nice if we don't have all our eggs in the same basket.
Very true. It's like, even one that doesn't cause a massive apocalyptic event is still going to cause significant, changes.
Well, if the Chelyabinsk asteroid, came in very flat, okay? If it had come in more vertically, directly over Chelyabinsk would not exist anymore, even though the actual asteroid did not impact the ground.
I didn't even realize that.
The shock wave would have been sufficient to flatten the city.
Wow. I feel like I could do an entire panel just on interesting asteroids or meteors.
Oh, yes.
Oh, yeah.
Millions of them.
This may have to be something we return for.
We've got another good comment in the chat.
Yeah, I was reading that too.
Oh, yes. In the bottom Sierra something says, also, they have to consider that impacts can be both prevented and caused. Just because we won't weaponize space doesn't mean China will do the same.
Back in the Star Wars days, the RAND Corporation, which is an Air Force affiliated, federally funded research and development corp, I think. I'm happy to be corrected on that, Michael. They did a study back around the Star Wars days, and they looked at weaponizing asteroids. That's actually hyperkinetic impactors. Okay, building a gun in space. Weaponizing asteroids is harder than people think.
Yeah, the whole idea. I think it was Purnell who invented the concept of rods from God, where you use a
tungsten penetrator.
Tungsten penetrator as an orbiting weapons platform. It sounds pretty cool. Unfortunately, it's a lot, like you said, it's a lot harder. And if you get it wrong, there's going to be some significant impacts. If you're trying to hit something that's on land and you actually hit the ocean instead, you've just gone from neutralizing an enemy capability to being possibly a mass murderer.
Yeah.
Well,
I had. Sorry, Steph.
I have a friend who is she's a budding novelist, and she came to me. I get a lot of other authors, small name, big name, no name, and they want to talk to me about a scientific concept and see if it works.
Mhm.
And she's like, I want to wipe out this island in the South Pacific. If I choose an asteroid of this size, will that do it?
Oh, yes.
And I went, yes. I promise you, the island will go away.
Do
So
you
will
like
the
LA?
entire so will the entire Pacific Rim. So
How do you like
and
LA?
so she generated a mega tsunami, with the impact, and it was just kind of like, oh crap, So yes, that is a consideration in things like that.
Yeah.
Sierra something asks about dropping them into the sun. I don't know. I
It
haven't
doesn't.
looked at the math,
That's
but
not how it works.
generally they're going to burn
No,
up.
it doesn't work.
For those
Yeah,
who are
that's not
audio,
how it
the
works.
question is, what about dropping them into the sun and causing solar flares? Would that wipe out? Or
You might, like if you threw Ceres at the sun really, really fast, that might work. But Ceres is the biggest asteroid we know about.
Now,
Yeah,
let's
I
put this
mean,
in perspective. Wait a minute, hold it. 1,000,000 Earths will fit in the sun.
Yeah, I think a
And,
lot of
and
people,
adding mass to the sun is not how you create solar flares.
Also true.
I think a lot of people don't understand how much bigger the sun is than the planets, because they have this picture of these little
right.
styrofoam balls from science class, and there's not a big enough styrofoam ball that the teacher could have bought that they could hang and still have room for the rest of the students
Yeah.
to be in the classroom.
Oh, we got a great comment.
In case that wasn't totally in your brain.
Put it like this: if you drop an asteroid into the sun, it's not going to make it to the photosphere.
It won't make it to the photos.
Yeah. Too little. We got a great
Yeah.
comment from Todd Caldwell that says, one of our FinCon panelists has expertise in asteroids. He has a t-shirt that reads, "Asteroids are nature's way of saying, how's that space program coming along?"
Thank you. What was I just saying? Oh, next Carrington event. Yes, that's
No.
oh yeah.
I'd rather not.
Okay, what's a
I'd
Carrington
rather
event?
not,
I haven't
Steph.
heard of
Okay.
it before.
A Carrington event. I've got a popular science book out there about solar and space weather, and it covers the Carrington event. The Carrington event was something that happened back in the 1800s, I believe.
Yeah, it was
My
1800s,
history.
like 1871 or something like that.
Richard Carrington observed a couple of what are called super flares. We're looking at the estimate. There are categories of flares depending on the energy of the flare. The most energetic flare is an X class. Each class goes up by 1 order of magnitude. Okay, so it's a logarithmic kind of a scale. So it is estimated, it should be X 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's as high as it actually goes.
Mhm.
But it's estimated that the flares that Carrington observed were on order X 99 to 100.
Yeah.
There were 2. One basically cleared out the interplanetary medium, which enabled the second one, the coronal mass ejection from it, to come in at a fraction of the time that it normally takes. You can think of a coronal mass ejection as like the mushroom cloud from the flare, but it's a lot bigger. It's a plasma. It goes out into the interplanetary space. And normally it takes anywhere from 2 to 3 days to reach Earth from the sun. The second coronal mass ejection from the flare took about 17 hours.
Oh, wow.
It interacted with the Earth's magnetic field. There were auroras literally from pole to pole. It generated induced current in any long distance metal object. This at the time included telegraph wires. There were multiple reports of telegraph offices burning to the ground because of the sparks generated. They were blowing out the batteries that were used to run the telegraphs. There were reports of telegraph poles burning down. They actually had the sense enough eventually to figure out we need to disconnect the batteries. And they were still able to send messages through the wires by the induced current in them.
For hours.
Wow.
Yes.
Memory serves
For days. For days.
Yeah, and the significance of
days.
this day is that basically it would shut down the global power grid.
Oh yeah.
Yes.
Well,
it would not just shut it down, it would collapse it.
Yeah,
Because
sure.
it would be blowing transformers right and left, and most of those big transformers are handmade,
Mhm.
I didn't realize
and
that.
they're not made in bulk.
Right.
And it can, the really big ones, it can take a couple of years to make, and they're not generally not stored.
Les was talking
Well, and
about
the
what
other-
happens when we lose the spacecraft or when we lose the space constellation. And I'm
Bingo.
not certain about this, but I don't believe most of our spacecraft are, or really practically could be hardened against radiation on that scale.
Some
some are, but not
some
not
are,
all of them.
but most are not.
But the problem
And the
is the
communication
ground stations
satellites are not.
Yeah, the ground stations that control the satellites are not hardened, and so it wouldn't really make a difference because you wouldn't be able to talk to the satellite anyway.
There has been a disaster prep concept thrown out there of wouldn't it be great if the United States would buy backup transformers and store them in the event that there's ever an attack, an intentional attack, to be able to replace damaged transformers from there would be a variety of things that would potentially destroy transformers that were online and potentially not a transformer that was in a
warehouse,
a warehouse or a warehouse with a Faraday cage, depending on how intense we wanted to be.
For those that are watching, a Faraday cage is designed to either keep electromagnetic radiation in or out. Your microwave is actually a very nice Faraday cage. I plan to throw my my cell phone, my watch, and my laptop into my microwave and unplug it.
The other thing to consider is that Carrington event happens, it's going to hit half of the Earth, right? The half that is it's going to hit half of the Earth. It's going to hit the half that's facing the Earth or facing the sun, and then roll across as the Earth rotates, right?
Well, no, because it's not radiation as such. It's not photons that's the problem. It's the plasma, and the plasma gets caught up into Earth's geomagnetic field and wraps around it. One of the worst things that can happen is when the Earth's magnetic field is shaped like a teardrop with the point pointing away from the sun. What can happen is if the CME impacts hard enough, it can wrap around and snap off that tail and produce something called magnetic recombination. And that energy will feed. That's what a flare is.
That's what makes the flares in the first place, right?
Right.
I feel like we can
that energy feeds back into the system, and it's a worldwide phenomenon.
And isn't it also the plasma compresses the geomagnetic field, and
that's why
also a problem when it returns back to normal, when it basically returns to normal size.
Yeah, it rebounds.
Yeah,
and part of that is because of the recombination.
It would be a really, really bad day. Okay?
Sierra something. We see you. I'm getting there. Do we know what causes Carrington events? Because I thought they weren't necessarily the same physics as standard solar flares.
Well, I mean, when it comes down to it, everything is EM, but it's magnetically induced.
Yeah, the sunspots are basically, you can think of them as snarls in the sun's magnetic field. All right. The sun is not a solid object. It undergoes what's called differential rotation. The poles rotate at a different rate from the equator. The photosphere rotates at a different rate from the core. All right.
Giant fusion explosion so big it can't finish exploding.
Yes, but it's also spinning. That's where the magnetic field comes from. Is you've got plasma moving in what amounts to a circuit, and that's generating a magnetic field. So what happens is, over time, the magnetic field lines wrap around and around and around and around, and they eventually form a snarl, just like your fishing rod line will do. And the more complex that snarl is, the more energy it contains. And it wants to simplify things. It wants to go from high potential energy to low potential energy. So eventually, magnetic recombination will occur. The magnetic field lines snap from their current configuration, and they reform in a simpler configuration. That releases all of that potential energy into kinetic energy, and that is a flare. All right? That can also blow away tremendous amounts of plasma in the form of a coronal mass ejection. And that is what is dangerous to us. That is what causes a Carrington event.
Hey, I want to
And
jump
the
back
other
over
thing-
to Sierra's question,
Oh,
because
Yes.
I think this notion of dropping things into the sun, I wasn't trying to say when I was talking about how big the sun is that it wouldn't be an event. I think depending on how big it was when it hit the sun, it would certainly have an impact. Several years ago, there was an asteroid that hit in Jupiter, right? And went in, and you could see the impact on the Jovian atmosphere, impact pun intended, right? And how it disturbed the atmosphere of Jupiter for quite a while after it hit. And there were a whole bunch of them that hit because it kind of broke up. And I think there's no doubt that there would be some kind of an impact in the near the sun from something like that happening. I don't know if it'd be a solar flare. I don't know what would happen, but something.
Yeah.
I mean, if it were big enough, I think we'd see the evidence of it. Now, whether it resulted in a
we've already
CME or not,
seen.
I have no idea.
Yeah, Les, we've already seen a number of comets break up as they get too near the sun.
Yeah.
Right, and that energy, that mass just feeds the energy of the sun. But the measurable effect on something that is that massive and that energetic, when you're adding a fraction of the energy to it in terms of potential energy, we would need probably a lot better sensors than we have today to be able to detect what impact, if any, it had on the sun.
Sure.
Yeah, but I'm wondering about we wonder if Psyche, the perhaps quasi-mythical M-class asteroid, right? That's an iron or a ferrous core, heavily metallic. For those listening, most of the asteroids we've ever seen, they're not like these rocks, like giant iron boulders flying through space. To the best of our knowledge, that's not we're not sure that's a thing. But I do wonder if because if you're going into the sun and you're picking up all that kinetic energy and you're turned into a fully ionized iron plasma before you do it, I wonder if interesting stuff happens. I don't know. I've never heard. I just, whenever I hear about Carrington events, I occasionally hear them. I occasionally hear the astrophysicists or the heliophysicists say, "Yeah, we don't really quite understand how you get a CME of that size or a flare of that size." But then I hear other people who don't even talk about it at all. So it's like it's not a thing.
When you consider that the melting point of iron is 2,800 degrees Fahrenheit, and the photosphere runs anywhere from 6,000 to 11,000 degrees Fahrenheit, as Stephanie said, it's going to melt long before it gets anywhere near the actual sun.
It's not going to just melt. It's going to sublimate. It's just going to go straight to vapor.
And it's going to turn around and go back
out. Yeah.
Which
No,
might have been
it's gonna-
that might have been.
No, I mean you're going to completely vaporize and ionize the material, and then it is going to reverse course and it'll become part of the solar wind. Is what you guys are saying.
Think of it as being like a comet's tail.
Yeah.
Some of it's going to be dust. Some of it's going to be gas.
I feel like we could almost do an entire panel on solar flares and Carrington events. In fact, I might do that because this is fun.
We can do that.
You'll need somebody who knows more about it than me. I can ask the dumb questions.
Oh yeah, I just realized though it is just about 9:28, so we went long this time, you guys. This is a whole lot of fun though. So yeah, we definitely need to do a space science 3 or at least solar flares. So I will probably be contacting you guys for more space stuff. But yeah, thank you for joining me tonight, and thank you everyone in the comments. We had some really good comments this time around. Before we close up though, first off, thanks everyone for watching. Thanks all of you for joining me. This has been a whole lot of fun. And I just want everyone to go down the line. Once again, say who you are, where we can find your stuff, what your latest book is, and then we will scoot for the night. So let's start with Les.
Yeah, Les Johnson. I have a website, lesjohnsonauthor.com. Also on Facebook, Instagram, and most recently doing stuff on TikTok. And just want to remind everybody, I've got my latest novel coming out in hardcover from Bayham Books next week, hard science fiction, Crisis at Proxima.
All right, Michael.
All right, so Michael Morton, very active on Facebook, both my own webpage, Mike's Adventure Gateway, and also with the Canon Publishing website or site, the Command Post. You can catch me there, either places. All my books are available on Amazon, so give it a look. See, like again, I write military science fiction, military supernatural, and given that I'm the fantasy editor at Canon, I'm going to be branching out into fantasy myself.
Nice. And Joelle and Andy.
Joelle Presby, let's see, X, Facebook. I do have a website, but let's ignore that for now. It's temporarily down for maintenance. The Dabare Snake Launcher remains my most recent novel, and I've got more stuff coming. It's just not ready to come out quite out yet. Stand by.
And Andy.
You can find my stuff on NASA's page, but you won't find my name. So go buy her books.
And Stephanie.
I'm Stephanie Osborn. I have a website, stephanie-osborn.com. No E on Osborn. I'm most active probably on Facebook. I do have a fan group, and I've got a group called the Osborn Cosmic Weather Report. I keep up with solar activity and let folks know if there's a CME headed our way, if there's going to be auroras, et cetera, let them know what's going on out there. So
nice. And thank you again. Oh, yeah.
I just wanted to add one thing. I'll be at MarsCon here coming up real soon in January.
Oh, yes, so
Canon Publishing. Yeah, so look forward to seeing everyone there.
I'll be at Conjuration later this month.
Oh, nice. Yeah, that is coming up soon. Where are you guys going to be, Joelle and Les and Andy? Are you guys have cons coming up?
Liberty for sure. Haven't decided on other stuff.
Mm-hmm.
Well, I'll be at the first European Interstellar Exploration Symposium the first week of December.
Oh, that's cool.
It'll be in Luxembourg. So
nice.
Looking forward.
All right. So plenty of places to see all of us. But thank you guys again for joining me. Thank you, everyone.